So I got my first energy harvesting device a few years ago. It was a cheap kinetic watch. It works by converting the wearer's motion, their kinetic energy, into usable power stored in a mainspring in order to deliver sustained mechanical work. This got me thinking. How much energy does the human body need? How much can it produce? Well, we need around 9,000 kilojoules per day just to maintain the system. That's the amount of energy we can convert from a food source into usable power for meaningful mechanical and biological processes, like breathing and maintaining body heat. At best, we can produce around 350 to 500 watts at peak performance for a short amount of time. All in all, our fuel efficiency is only around 15 to 25%. The rest of that energy is lost to the cosmos, converted to heat, sound, and motion. What if we could capture that waste energy and put it to work? That's where human energy harvesting comes in. It's the process of converting that energy into usable electrical power. And there's several ways you can do this. Vibrational harvesters, which utilise a piezoelectric material that creates a charge whenever it's stretched or contorted. Thermoelectric generators that utilise the temperature difference between a wearer's body heat and the ambient room temperature in order to create charge. And kinetic harvesters that capture the motion of ordinary everyday activity, like my watch. Now, I'm particularly interested in kinetic harvesting, so let's start the physics lesson there. So, 1850s, Michael Faraday showed through experimentation that by passing a magnetic field about a wire coil, you can induce an electric current. Vice versa, by putting an electrical current through a coil, you can induce a magnetic field. Nikola Tesla later showed that by rotating multiple coils about a fixed magnetic field, you create an AC polyphase generator. That's how we get most of our electrical energy today, and it's the basis of kinetic energy harvesting. So the thing about AC, alternating current, is that you're producing both positive and negative charges and sending them down the line. They flick between the two. Now that's fine if you're powering a simple light globe. Normal filament-based globe doesn't care which polarity flows through it. So long as there's charge, the resistance in the filament will produce heat and light. That's not the case with complex electronics. Things like diodes and capacitors need the correct polarity to flow through, or they just don't work. You need to do what's called signal rectification. That's the process of smoothing out that signal so that only the correct polarity flows through. Okay, so now that we've got a usable electrical power, what do we do with it? So I'm also interested in wearable and implanted devices. Things like powered prosthetic limbs, focused neural stimulation caps, wireless body area networks that collect the wearer's vital signs, their bloods and respiratory signals. Now, in many applications, human energy harvesting could be used as a power source, as either a charging mechanism for batteries or as a complete replacement to battery power. This is particularly beneficial in the case of implanted devices. They're hard to get to. Changing the battery often includes additional invasive and potentially risky surgery. In the case of wireless sensor nodes, changing the battery is actually a destructive process. You can't put that back in. Imagine then a device that was powered simply by being on or in a host user. This device would be much more practical. It would improve the wearer's mobility and general quality of life. With around 450 million connected wearable devices, that's the wrong slide. So this isn't just a pipe dream. Research is currently going on around the world in places like SAIT in South Korea, DARPA and NASA in the United States, the CSIRO here in Australia, and me. All looking at ways of converting the human body into a power source for wearable and implanted technology. Now, With around 450 million connected wearable devices in Australia, that's not a small market. In fact, later this year, the Wearable Technology Conference is taking place in Sydney. This will see investors and innovators, researchers and retailers coming together to find ways to tap into that market. Perhaps one of the things they should be looking at is how human energy harvesting can be used to put our waste energy to work. Thank you.